Hey guys, in this video I'm going to explain what I did for each of the problems on the study guide. So I did post an answer key of the study guide. What you see here on the screen has been posted, but what I'm going to do is just kind of break down each problem and make sure that you're good to go for the test. Alright, let's take a look at the front page of starting with number 1. Alright, in number 1 I have a absolute value function, and you guys are plugging in 3 different numbers for it just to get lots of practice. So when we plug -4 in, as you can see here on the answer, or in this answer document, all you're doing is plugging it in for the input, and then you're getting your output, right? So -4 minus 1 is -5, but when you take the absolute value of that, you're going to get your +5 here. -3 times 5 is -15. Add 1 to that, you get -14. Okay? The next one, plug in a 2. 2 minus 1 is 1, so that's how I got this 1. -3 times 1 would be -3, and -3 plus 1 is -2. Alright, plug in a 6. 6 minus 1 is 5. Absolute value of 5 is also 5. -3 times 5 is -15. -15 plus 1, -14 again. So there's number 1. I don't think we had any issues with it. Number 2, this one might be a little tricky for some, but once I remind you how these work, one of the reasons why I have this one here is because we've been doing piecewise functions on our weeklies. It's been a while, but on the first few weeklies we've had them, and then we also talked about piecewise function at the beginning of the year. So let's remind ourselves how this works. So if our input's -4, with a piecewise, you got to figure out which function does it belong to. Okay, so -4 would fit in this domain restriction because this one's saying x is less than or equal to -2 and -4 is less than or equal to -2. So you'd be plugging -4 into that function, and when I did that I got 0. Okay, when I plug in a 2, the 2 would fit into this domain restriction. 2 is between -2 and 3. 2 squared is 4. 4 minus 3 is 1. Alright, plug in the 6. 6 would go into this last section because 6 is greater than 3. 6 plus 3 is 9. Square root of 9 is 3. Okay, so there's your number 1. You're going to have at least one problem like this where you're just strictly evaluating on the test. Hopefully you're feeling pretty good about that. Alright, next section. And you're going to have 4 questions, just like you see 4 questions here, going over each operation. So the first one, we're just adding f and g together. When you add the 2 together, the parentheses really aren't going to do anything, so I did not put parentheses around my 2 functions. I just kept them separate, put an addition sign in between, and then I combined like terms. Okay, so here was the h function. It was 3x squared minus 3, and then here was the g function, and then I combined the x squareds to get 4x squared. I combined the x's to get -6x, and then there's that plus 1. Now some of you guys might be asking, well, what about these domain restrictions? How do we find those? So if you remember when we first went over this lesson, I told you guys that if the 2 original functions do not have any domain restrictions, then when you add, subtract, or multiply, you're also not going to have any domain restrictions. So what that means is, if I'm looking at these functions, this is a squared function, that's a parabola, right? So that is going to be all real numbers for the domain. You can plug any number in and get an output, positive or negative. Same thing goes for g. You can plug any number in and get an output. That's another quadratic. And then for h, it's a linear. You can plug any number in and get an output, right? So all of those given functions, their domain is all real numbers. So when I do the sum of those 2, it's going to be all real numbers. When I do the subtraction of those 2, it's going to be all real numbers. And then when I do the multiplication, it's also going to be all real numbers. Now the one that we typically have domain restrictions on is the division problem, okay? So these first 3 should be all real numbers, and you can also see, because when you put the 2 functions together, what are you left with? Well, you're left with a quadratic, and you don't have any domain restrictions with a quadratic. You can plug any number in and get an output. Let's take a look at number 4 real quick. So I did put the second function in parentheses, and I did that because I'm going to have to distribute the negative. Okay, so when you subtract, don't forget to take care of that negative by distributing that to both. And you can see I did that and got negative 2x plus 5. Okay, and then I combined my like terms, and that's how I got my 3x squared minus 5x plus 5. All right, no domain restrictions on that one. Number 5, I multiplied. Make sure you distribute. Make sure you add the exponents when you're multiplying variables. So 3x squared times 2x, that's how I got my 6x cubed. 3x squared times negative 5, made the negative 15x squared. And then I switched to the second number. Negative 3x times 2x is negative 6x squared, and then negative 3x times negative 5 is positive 15x. Once I multiplied them, I combined my two like terms, which were the x squareds, and that's how I got 6x cubed minus 21x squared plus 15x. Once again, no domain restrictions. Now number 6, when I divide the two functions, I took the h, which was 2x minus 5, and I divided it by 3x squared minus 3x. But whenever I do that, for division problems, you have to remember the denominator cannot be 0, right? If you divide by 0, that's an error. That is a domain restriction. We can't plug in those zeros. So what I did is I factored the bottom out, and really you could keep your answer like this. That's good. All right, you can leave it that way. But what I did is I factored the bottom, and the reason why I'm factoring the bottom is I'm asking myself what's going to make those factors 0. So what would make 3x equal 0? Well, when x is equal to 0. What would make x minus 1 equal 0? When x is equal to 1, right? And I don't want zeros in the bottom, so what I said is x cannot be, so it's all real numbers, but x cannot be 0 and 1. Those are the only domain restrictions. And if you were to graph this, you're going to see that your function doesn't have an output at 0 and 1. It's going to say error. That's telling you that it's a domain restriction. All right, let's jump down to the next section, composition of functions. You're going to have two straight up compositions like these, and then you're going to have like two more, I believe, that are tied into the test, but two that look just like this. Now number 7 is probably a little bit more difficult than one I would put on the test, but this is something that we did do in class, so I did want to show you how that would work. So for number 7, I'm taking the h and plugging it into the g function. So that's what this notation means right here. Take the h, plug it into the g. When you do that though, when you plug that h in for the input on the g, you see that I have to cube that. And when you're cubing something that's a binomial, that's where it gets a little messy. So I started by just squaring it, which is this, and then I had to multiply that once more by 4n minus 5. And I end up getting this guy right here. Okay, so I got all of that, and then I had a negative out in front. So what I did is I distributed the negative to everything. And let's see. So if I distribute the negative to everything, which I already did, I switched the signs inside of that highlighted in green. I just can't forget that step. So make sure, it's hard to see, but there was a negative out here. Make sure you switched all the signs, and I did that. I switched the signs inside, okay? For the second part, this negative 3 needs to be multiplied to 4n minus 5 squared. I just went back here and saw what I got for 4n minus 5 squared. And then I multiplied those by negative 3's, and that's how I got this guy over here. Once I've multiplied everything out, I combined like terms, and I found it to be this. If you see any errors with my work, let me know and I'll double check it. But looking at my work here on the side, looks like everything's good. Okay, so I got negative 64 n to the third plus 192 n squared minus 180 n plus 50. And once again, on your test, you're not going to have one where you're going to have to expand it out to the third power. You may have to do a square, but you're for sure not doing a third power. All right. Number 8. So we're doing f of g of x. So this means I'm taking the g of x and plugging it into the f of x. This one's a lot easier because the f of x, I don't have any exponents. So I'm just taking that g of x, plugging it in for that x, and that's what this looks like. Okay? I did have to distribute a 2, and then after that, nothing combined, so I was left with that 2x cubed minus 8x squared plus 5. All right, hopefully no questions on 8. Let's move on to number 9. Okay, so for number 9, I'm taking -5 and plugging it into the f function, and that's how I got this -10. And then I take the -10, and that's the input of the g function. So I plugged it in for the variables for the g function, and I got my -45. Number 10 is very similar, but you're starting off with a 0. Okay, and you end up getting -5 as your output. All right, this is your page 1. In the next video, I will be doing page number 2. Thanks for watching, and I hope you're finding these videos helpful.